Hello everybody, thank you for joining us today for this presentation on high performance rotary sealing. Myself, Darren Conway, and Paul Leadley will be taking you through the content we have for you today. We want to talk to you around our product, which is the high spin PDR, and we're going to take you through that over the next 20 minutes. And if you have any questions, please feel free to write them in and we'll answer them at the end. So if we go on to the agenda. So the agenda is we're going to give you a product overview. We're going to talk a bit about benefits and features, tell you a little bit about our product development process, share some case studies, and then bring that all together in a summary. And that's the brief agenda of what we've got planned for today. So just to introduce the product, I mean, the product that we produce for high-speed rotary sealing is high-spin PDR. And the unique point around the seal is it's a PTFE contact seal. And the benefit of this is that it has a number of areas where it is very strong. So it can operate high speed, it can do dry running and low friction, as well as other things which Paul will go on to talk about later. Another area which is great about the product is this product's been around for around 40 years. So we developed a lot of experience in that time of use of this seal in various sort of applications and segments. And to talk a little bit more about that, this will just give you a little bit of a flavour of the segments that the PDR product is used in. So areas like aerospace, automotive, particularly moving into the new e-mobility area, food and beverage. And because of the precision and reliability of the seal, it is really well thought of in these segments and really a choice seal. So things like gearboxes, motion controls, compressors, vacuum pumps are ideal areas for this seal to do well. And as we move more into electrification markets, where we move away from wet systems, the seal really comes into its own, where it's more dry running and low friction is key. And I'll just hand over to Paul, and he's going to talk you a bit more about the product.
Thanks, Darren. So one of the primary benefits of PTFE is its low friction, and that enables us to do lots of things. Now, of course, there are radial oil seals on the market. They're a very well-established product. They serve a great purpose, but they're relatively speed limited and need to be well lubricated. Now, the low friction that PTFE can contribute allows us to run faster and at lower lubrication levels, while also generating less heat and consuming less power from the prime mover of the source that we're applied to. So there is a primary benefit in the friction that PTFE can bring while still being an effective seal. Another benefit that PTFE has, especially when compared to elastomer products, is that it has almost universal chemical compatibility. So we don't really have to worry about what the media is. The PTFEs that we use are universally applicable. There's also a benefit that the temperature range that the PTFE can operate over is quite wide compared to other products on the market. So at the high end, as well as at the low end, we can provide good sealing in a wide variety of media, and also over variable lubrication levels. So everything from dry running to low lubrication to flood filled sealing are available with the PTFEs. So it's a universally compatible material with a very wide temperature range. We produce the PDR in two manufacturing styles. On the left here, you can see the crimped version of the PDR, which has a relatively simple bill of material, only a couple of components. It contains a machined body, and what that allows us to do is to customize the body to whatever the customer needs. So if it's a larger diameter or it needs to have extra flange components or an O-ring on the outside, we can add those components to that design. On the right, you can see a simpler construction using relatively simple stamped components, our clamped design. Those are more suitable for high volume and also are simpler components and also at a different commercial point than the crimped version. Both of those product families are available in all the sealing elements we'll look at and materials, and in both cases we have a standard product range that we can offer. So whichever of the seals is the appropriate one for your application, we have a few styles which are our core, our go-to solutions. So everything from our type A seal, a simple single element with seal up to 5 bar or so, or a type C where the pressure is higher, maybe up to 10 bar in a rotating sealing application. If there are different requirements, perhaps we can use a type B where we have 2 elements, and with that we can change the function of the 2 elements. So we can add back pumping on the first element, sealing on the second element, or even conductivity on the second element, as we'll talk about later. A type D seal would be sealing 2 separate medias from both sides, where a type G is sealing oil or the media on the left in this case, and the right-hand side is an excluder for dust or dirt from the environment that's external to the application. And within those styles, we have a range of PTFEs that we can offer with different fillers to achieve different jobs. This is just a snapshot of some of the blends that we use most commonly. So T25 is a compound that's very good for well lubricated oil systems. T40 is our go-to material for water sealing, especially. T78 can be used on soft shaft surfaces, and QD1 is our most recent application for low lubricated, high speed applications. So a lot of the electric motor applications would use that as a material. We also have a range of MF grade materials which are certified for food and beverage applications. This slide depicts the breadth of capability that we have within the Trelleborg team. So we have a global product engineering capability with a lead center. In that center, we try to anticipate with the extremely accelerating needs of technology, the sealing capabilities that will be required to support it. And we have both computer-aided tools and also an extensive lab facility where we can validate new materials and new types of seal to suit those needs, supported by the materials development from the core of Trelleborg. One example of what we have been developing is conductive PTFEs. So these can be used, for example, in AC motor applications where there's a tendency for a potential to develop between the rotor shaft and the chassis, which can eventually damage the bearings. We can offer a rotary seal material which has an equivalent static and dynamic performance to a shaft grounding ring, and also the same life and no carbon dust. So it's just an example of where we've used our materials development and application understanding to go beyond just sealing.
Thank you, Paul. So I'm now going to take us through some case studies that we're going to share with you around different segments and applications to give you an idea of the breadth of capabilities of the high-spin PDR. And I think we want to start with aerospace. Aerospace is a great market. It has a lot of reliability requirements. Life is key. Any time where an aircraft is on ground is costly to the operator, and very critically, which is a really important point, is safety is incredibly important with any aircraft and vehicle. And that's where the PDR product comes into its own. The precision sealing and low friction characteristics means that it's perfect for things like gearboxes. It's got a great wear resistance, so the life of the product is very good, and it means that they can meet the stringent requirements around long life requirements around the product. I mean, another great feature on the product is that it can be combined with other requirements. So, for instance, if there's a requirement that the PDR seal needs to be rubber coated, or some contamination or leakage requirements, we can rubberize the jacket of the seal to add an extra benefit. If there's other features that they would like to integrate into that seal with multiple lip designs or other features so they can reduce componentry, that can also be brought into the seal design, which is another great benefit of this style of seal. If we move into the automotive market, and as we spoke about earlier about the move more towards e-mobility, we're seeing a greater move for electric cars and demands in the world, and with that makes a trend of moving from wet systems to dry systems, and that means reduction of lubrication, and with that a need to be able to run with less lubrication or in some instances even dry. And that's the great thing with the PDR product. It can meet those challenges with the low torque features, which is required around electric motors. And what we've been able to do around our global manufacturing footprint is embrace more volume related capabilities so that we can meet the challenges that are required in this market. And you know, this is an example of the electrification area where these steels can really come into their own. Another area is the semiconductor industry. Now, the semiconductor industry have some high requirements around cleanliness, and also they have a lot of chemical compatibility requirements. And that's where PTFE is very good. It's very chemically resistant. So these seals can be used around a lot of the various chemicals that it can come into contact in semiconductor applications. It also is very consistent and reliable. So when we're making precision components in the semiconductor industry, these seals can give a very reliable, consistent performance and given them low friction requirements they reduce throughout the process. You know, we talked more about electrification. Another area is robotics. I mean, what we're finding with robotics is the globe is embracing this area, and we're seeing the demands on robotics getting larger, and we're seeing more robotics move into industry. It's even moving into the home. And with that, the demands on the sealing components become greater. So longer life on these seals, smaller diameters is another area where the demand is there as well. And again, the high-spin PDR fits into this area where there is low lubrication and these requirements for a longer life are needed. And there's various applications that we service into where these products are utilized and fit into. And then the final case study I want to talk you through is this one where we've used a case design. Where we were talking earlier around that blend between performance and cost sensitivity, this seal comes into that right area where some of the application demands maybe not as challenges as we've seen in other areas, but it still needs that level of reliability, and therefore it needs a certain cost area we need in the system. And this is where we can utilize our CAN design to fit into that. We've also embraced automated technology so that we can meet the high volume demands required for these products. And again, I think this is a great example of where we can blend the two different seal designs and still meet the demands of various segments and customer applications. And I think just to bring all that together and to sort of give you an idea of the overall message that we're trying to convey around this outline that we've been through on the high spin PDR is that, you know, its key area is that it's a high speed seal. And more in these demanding markets now, we're seeing that people want more high speed requirements. They need to be able to run at high speed. It's great at low friction compared to maybe radial oil seals where there's a higher breakout friction or there's a higher friction from the elastomer contact. These seals will give you a much lower friction. Again, both seals are good and they play a different part in the sealing portfolio. And with the Trelleborg brand, we, you know, across our high spin range, we offer the radial oil seals and we offer the PTFE contact seals as well. But it's about picking the right seal for the right application. And here we have the low friction capabilities combined with the high speed, which really do give it its benefits. And then a couple of areas which we spoke around, things about high and low temperature and chemical resistance. So for instance, things like cryogenics, areas where you get really low temperatures, you know, the PTFE works very well in those markets. Or even if we go to things where you've got biopharma, where you've got aggressive chemicals, the PTFE again is very resistant and can fit in these areas. And as we spoke about the segments that we've got pedigree in and we've supplied for over the 40 years, semiconductor industry, aerospace, e-vehicles, chemical processing, biopharma, drives and motion and robotics are just a few. And it's where industry needs reliability and accuracy. And that's where the seal really comes into its own. And as we said before, we offer two retention methods. So we have the canned and the crimped, and they allow us to offer different features for our customer. So depending on what you require, we can tailor the solution to fit. So if you need additional features making into the seal, we can do that. If you need looking for a more standard range that's got a more sort of basic function, although still very challenging, admittedly, we can tailor that. And in addition to that, if you needed to implement something like a wear ring on your shaft, where you want to have a different materials, we can help you with your wear ring design as well and implement that into the sealing arrangement, and even supply that as a kit. Our global support is truly global. We have a global design team in the US, Europe, and Asia. And that means we can support our customers locally. We can leverage that global experience, but what we can do is make sure that we're local to that customer so that we can use their lead time to be able to sort of talk in real time to them. We have dedicated high-speed test capability within our facilities around the globe. And I mean, what that means is that we've got two areas. We've got product development, where we're constantly developing our product, but also that other area where we've got that product development we can do with customers. So what we do like to do is work with our customers, whereas they have certain requirements and needs, we can test that. So no need to take that development and testing into their factory or to where they want to in their test capabilities. We can do that testing. We can go away, we can understand your needs, and we can do the testing to develop those sealing capabilities that you require and develop that partnership that really makes sure we have a successful solution. And we support that with cutting edge FEA technology. And we also have 3D CAD so that we can see that in real life. And just to summarize around the demands for the future, what we're really starting to see is the electrification market really coming in now. And what that means is a move away from wet systems. So reduced lubrication, a higher focus on reduced torque, friction on seals. And that's where the PDR comes into its own, and it's really a good fit for these markets. And it's well positioned to meet these needs. And I think that's where we come to our end. We come to question answers. I think I've put my contact details and Paul's contact details on there. I think if you have any questions and you'd like to contact us, please reach out and give us a call, and we can, or an email even, email, and we can help you with that. And we'll just have a look and see what questions have come in. So I'll just have a look. Question number 1. Which PTFE seal design material is best suited for larger static and dynamic run out? I'm going to hand that over to Paul as the more technical expert on the call.
That's a tough one to start with.
It is.
So we have our standard range of PDRs where you can pick from the catalogue what shaft, what housing, and off you go. And you can choose then the material to suit the media you're trying to seal. When we get beyond that into customized solutions, we'll try to give you the best thing that we can come up with as a combination of the body and the material to give you what you're looking for. So for example, if you have a large flood-filled environment or a large high-speed environment, the solution might be a different material, might be a different element, design type even. So for static sealing or dynamic sealing, we tune it to the application. We do have design types which are much more tolerant to larger dynamic runouts. Sometimes we see that on, for example, aerospace gearboxes, that kind of stuff. And we can design that when we're doing the FEA for the element design, we can build that in so that we know we're looking for an element that can flex more with a higher run out. So the short answer is it's a combination of the application conditions and our understanding from previous experience that comes together in the FEA, and then the answer is the element design that we produce. But we absolutely can do large runouts if we need to.
Yeah, and I just add to that, Paul. I mean, Paul is spot on with that. It's about understanding the complete application in its context, and therefore we can use our experience through our many years of experience to come up with the design that fits best for your application. So that relationship and understanding your application and the full specification is incredibly important to make sure we design a product that is going to fit your needs. Question number 2. Let's have a look at that. What capabilities does Trelleborg have for lifetime performance testing of PTFE seals? Where are the facilities located? I can. Do you want to go, Paul, or
I can take that one.
go on?
So we've got test facilities around the world, as well as design facilities. So in the UK, for example, we have multiple rotary test heads that can do up to 24,000 RPM and up to about 140 degrees C. And we regularly test seals to 1,000 or 1,500 hours of life to see how much of the element life is left at that point. We can replicate that across North America and also Asia in comparable test facilities. So again, what we try to do is get as close as we can to the application conditions and try to remove at least some of the risk. And of course, we don't have the same vibration or, perhaps environmental conditions as the application, but we can certainly do temperature and speed in any one of our development facilities.
Yeah, absolutely. And we can actually get along. I mean, our test capabilities are very well developed, that we can simulate a lot of areas of elements where we can, we can do a lot of life simulation to come up with some the appropriate solution. Okay, number 3. Is it possible to integrate high spin PDR with other components within assembly? Yes, is the answer. So there is various options you can combine the high spin product with other requirements. So not only can you have multi-lip design, so to integrate maybe a dust lip feature with a sealing feature, you can then start to integrate other elements. So for instance, for another example was the wear sleeve. Sometimes the customer needs to make the rod out of a different material, and they just want to locally have an area where the seal is going to run on, and we can design that and add that in as a kit. But also we can do things like rubberize the outside of a seal, so that helps in things like aerospace where they've got leakage requirements. And then, as Paul alluded to as well, we can build in things like conductivity into the seal. So instead of having two seals, you could have one seal which has a conductive capability in one sealing element, and then the other element could be the other working seal. Thank you. I think that was oh, got another one. They keep coming. Could you share some more information about your product development process? Okay, I'm going to sort of talk about that a little bit. So I think we touched on it a bit before. So within our R&D network, we have various testing capability, and also combine that with our innovation community within our company. We can sort of look at what are the next trends going to come, and then the really important factor of that is our customer. So we're listening to our customer, and we're working with our customer to understand what are the demands they're seeing, what are the trends they've got. So we take those together, and we can start to go on 2 channels. We've got product development, where we can we're constantly developing our product, and the benefit about this is it helps us improve our customer product at the same time. And then strand number 2 is our partnership with customers. I mean, how we really love to work is with a partnership with our customer. We love to be able to sit down with them and agree a product development plan where we together can bring together our experiences, us as the sealing expert and our customer as the equipment expert, and we can run a test program where we can have the best chance of success by bringing our experiences together and seeing 2 sides of the application. So that in summary is how our product developments work. So that is the end of our questions. So we're going to bring the session to a close. I just want to thank you on behalf of myself and Paul for joining us today. We hope we hope you found something interesting. As I said before, please contact us, and then please have a look at what's coming up on the next sessions. And there's lots of really interesting things you're going to find, and I hope you enjoy yourselves. Thank you very much.